Hello, my name is Sonu M. I belong to batch 2 of Data Science and Analytics course in ICT Academy. As a part of my course, I am hereby conducting a case study on Python Flask. The objective of the case study is to create a web application using the given iris dataset to take feature input from the user in a web page and to print to which species the given data is classified. So as a first step of the classification case study, I created a Jupyter file in using Python codes, and in this Jupyter file I imported the important libraries pandas, numpy and all, and then loaded the given dataset and checked the basic details of dataset. And also I have done pre-processing on the dataset. On pre-processing, it is found out that there are no null values present, and also there are some duplicates present in the dataset. So the duplicates in the dataset are dropped. Then exploratory data analysis is carried out and some useful plots of the dataset is being made, and then move to the model building. In the model building, the given dataset is divided into the features and target column. In the features column, all the values, the sepal length, sepal width, petal length and petal width are taken, and in the target column, classification is taken. Then the train test split is being imparted into the model and then move to the model building. On the given dataset, I have already built 6 different models named logistic regression, KNN model, decision tree model, random forest model, SVM linear kernel model and SVM RBF kernel model. And the accuracy scores of all the 6 models are evaluated. To reassure the efficiency of model, I have also done the cross-validation of models, and the CV scores of the 6 models is also found out. On analyzing both the CV scores and accuracy scores, it is found out that the SVM linear model is the best model suitable for the given data set. After doing that, I saved the given CSV file under a different name, iris svm1, which is the pre-processed CSV file. This file will be the pre-processed one which is to be fed into the Spider environment. Before creating a successful web application, I have already created a successful home folder here, which will include all the necessary files for the web application. In the home folder itself, I have added model.py file, app.py file, the 2 different data sets, the already created Jupyter file, and 2 subfolders, static and template. In the static subfolder, inside the CSS subfolder, I have added style.css file, and in the template folder, I have added the index.html file. All these files will be required in the Spider environment. Here we can see the Spider environment. First of all, I created the model.py file. In the model.py file, all the important libraries are imported. The given dataset is loaded, and it is again splitted into features and target, and train test split is imparted, and the best model, that is the SVM linear model, is tried on the given dataset. And this is saved using a pickle file using the code pickle.dump of SVM linear. I have written to the pickle file, and then this pickle file is again loaded, and some random values 6, 5, 4 and 3 are given to this model, and then check if it is working fine, and it correctly prints the classification species as iris versicolor. Then moving to the app.py file. In the app.py file, after importing the important libraries, the flask function is called by its name, and then an home function or a home router is being defined here using the render template of index.html. This index.html is a basic page to create the web page, and the index.html, in the index.html I already added the style sheets, which is to make the website more beautiful. In the style sheet, I have added the different font sizes required, the letter spacing required, and the text shadow effects required and all. And in the index.html file, I have added head and body section. In the body sections, I have already added a style sheet in the background to make the website more beautiful, and then enter the floral measurements as a heading, and then 4 different values. The sepal length, sepal width, petal length and petal width are to be taken from this index.html file. On clicking to the submit button, this will be returned back to the predict function in the app.py file. In the predict function, these entered values will be converted as a float values, and then the values will be predicted using the prediction test command, which will be displayed right below the input values on the index.html file. Then on running the app.py file, I have already got an local host address, and I'm copying paste that local host address into web browser and running it and successfully getting a local hosted web page here. To check if it is working fine, I'm entering some random values here, 5.3, 1.6.2, and predicting here. I got the classification species as Iris setosa. Now the next step, I already created the local host. Now I have to create a global website or a web application which is to be used by everyone. So for that, I use the pythonanywhere.com. In the pythonanywhere.com, I have already added all the files, the pickle file, the flask file, the index.html file, the style sheet, that all created into this environment and uploaded it. And then after that, I reloaded my website, and a successful configuration for my web is got from this website, and it is sonum765.pythonanywhere.com. On copying paste this URL to a web browser and running it, we can successfully see the web page created using the local host address. Now to check the efficiency of the model, I am randomly inputting some values to check if my model is working fine. I given 5.2, 3, 2.3, and clicking on the predict button, I get the classification model as Iris setosa. So the web page is now working fine. So the objective of my case study was to create a web page or a web application to input values from the user and to predict the classification species, and through these steps the objective of my classification species problem has been completed. So thank you.